Paul McWhorter has a tutorial series on the Raspberry Pi Pico microcontroller. In lesson 12, he discussed a LED package that has 3 LEDs in one unit. They are the red, green, and blue LEDs that represent the primary colors. And from these primary colors, by mixing them, you should be able to get any color you want. The package has 4 legs. In this picture, you will see that the leg on the left is connected by way of a current limiting resistor to GPIO pin 15 of the microcontroller. The leg next to it is connected to ground. This is the ground rail, and farther up on the microcontroller, there's a connection to one of the ground pins on the Pico. To the right of the ground pin is the green LED, and it's connected with another current limiting resistor to GPIO pin 14. And the leg on the right is the blue LED, and it's also connected with a current limiting resistor to GPIO pin 13. Now in this case, I've selected all the resistors to be the same. They happen to be 220 ohms. Had I known the forward voltage drop across each LED, the value for each resistor could be calculated, and they would not be the same. But since they are the same, the intensity of light from each LED won't be the same. Now, also on this breadboard, I have a potentiometer wired in, and it's not being used in this assignment. It was used in another assignment. Now, to get the colors that we want, I'd like to refer you to this table that I found online to get the various colors from 3 primary colors. Now, this table assumes that the levels are all the same. So, for instance, for white, all the LEDs would be on at full value. Now, the table is using an 8-bit color value, so the maximum number is 255. In our case, we will be using a 16-bit value, and that maximum value is 65,535. Now, if we look to get red, you just turn on the red LED at full value. To get green, they call it lime here, you turn on the green LED, and of course to get blue, you turn on the blue LED at full value. To get yellow, you combine the red and the green, and they have those both set at full value. To get cyan, you combine the blue and the green. To get magenta, you combine the red and the blue. Now, to get other colors, he also asked us to do yellow and orange. Well, for yellow, I came down to this chart here, and I used the value for the gold. It came closer to what I saw as yellow emitting from the package. And you'll notice that for this one, they use a red value of 255 or full value, a green value of 215. So to find out what value we want, we would divide the 215 by 255 to get what fractional part of the full value we need. And the other color that he asked us to do was orange. And in this one, they're using the full value of 255, a value of 165, and so we'll divide the 165 by 255 to define what fractional part of the 65K we want to get orange. And then we also were asked to get white, and white is all 3 LEDs on at full value. Now, since I'm not using resistances to give us the same intensity of light from each of the LEDs, you can compensate that by adjusting how much voltage you're supplying to each LED. And we're using a pulse width modulation to provide that voltage. Now let's look at the code that I've written for this assignment. In step 1, we've imported from the machine library 2 modules, the pin and the pulse width modulation module. That allows us to define what pins we're using and that we're using pulse width modulation. In steps 3 through 5, I've defined what pins are being used for each color, or for each LED. We're using 15, 14, and 13 respectively for the red, green, and blue. And in lines 7 through 9, I have them set up that we're using pulse width modulation. Now remember, in pulse width modulation, you're rapidly turning off and on the voltage to each LED. And in this case, we're doing this 1,000 times per second. And then we have to tell it, when we output, what the duty cycle is. Well, the duty cycle is how much time during that each pulse the voltage will be high. So I have initially set each of these up at 0. So if when we start the program, all 3 LEDs in the package will be off. And as I've mentioned before, we can write a maximum value of 65,535 to each LED. If we're writing the full value to each one, we're going to be providing 3.3 volts to the circuit. That is the voltage across both the resistor and the LED will be 3.3 volts. Now I have this recommended values set to false, and the reason is, remember that we can't be sure that the resistance that's been provided will provide the same intensity for all 3 LEDs. So I have 2 sets of arrays set up. The first set is based on the colors that would be the voltages that would be provided, or values that would be provided if the intensities for all the LEDs were the same. So if this is true, we would set these all up. And you'll notice in this we have, for each color, we have an array of 3 elements, one for red, green, and blue. So for instance, for the red, that means we multiply the maximum value by 1, and for red, and for green and blue, we multiply it by 0. So only the red is on at full value. And the recommended values are listed for each of these. If we come down here, for instance, for yellow, remember I said I chose gold. We're going to multiply the 65K by 1. We're going to multiply the green by a fraction of 215 divided by 255, and we're going to multiply the blue by 0. Now, since they're not all the same intensity, I've defined another set of arrays with 3 elements. And what I've done is, if we come down to where we have multiple LEDs written, I've played around some with the values to get something that to the eye looks closer to what we were trying to get. For instance, evidently the green and the blue, I've made them a lot dimmer than you would get if we looked up above at what the cyan recommended value is. We're not outputting the full amount. And I've done that for all the colors except for the 3 LEDs that are on alone. So I've just ran the program over and over again and plugged values in there until to the eye it looked closer to what I was wanting. And then so when we look at this, I have this condition that I have set to false for the recommended values. So if that is false, we don't want to use the recommended values. We want to use these values that I've done some tweaking with. And then I have another array for each of the colors. So that means if somebody is selecting the cyan, for instance, cyan will refer to this array. So we really have here an array of arrays, a 2-dimensional array. And that will allow us to calculate what value we're setting out to each LED. Then I have another array that has a string value for each color: red, green, blue, etc. That's so that I can build a menu for the user to select what color they want. So if we look at the rest of the code, this loop is, while true, that means it's always true, so this loop is going to be running over and over again. At first we display this line, select the number for the color. And following that, I have a for loop that says for the values of I in range 8, that means we can have the values from 0 up to but not including 8. So for each of those, I'll display a line. And for instance, if the first one will be I is 0, so it says, you up here you say enter the number for the color, and below it it'll say 0 for the color, and the color is 0, and we look up here in this array and it's red. And so it'll display red. And following, it'll do this 8 times, and then it'll ask for a number to be input. And the number has to be from 0 through 7. Notice I don't have any validation code. For the demo, I'm assuming that they're entering valid entries. To be more precise, I would have to have a lot more code in here to make sure that they've entered something valid. If not, I would have to take some alternative action. So when they enter the number, let's say they've entered a 0, so we have to calculate what do we want to output for each of the LEDs. So we take whatever they've entered and make that an integer, because remember, when you enter something, it's entered as a string. So we convert that to an integer, and let's say that they've entered 0 the first time. So the the array of color looks at rather the multiplier array looks to see what color number they've entered, and if they've entered a 0, we go up and look at element 0 in the multiplier array. And remember, this points to another array of 3 elements for red, which would be 1, 0, 0. So we multiply the 65K by 1 for red, 0 for green, and 0 for blue. And then I display what values it calculates, and then I output those values to the LEDs. Now let's run the program. Now you notice I have a diffuser on top of the LED. The LEDs don't show up very well on video cameras. So we diffuse that, and that helps somewhat to display something a color that we're interested in. But it turns out that I'm using a webcam, and the webcam does a lot of auto-correcting. So the color that you see here may not be the same as what the eye sees. But let's run the program and see what happens. So if you come up here and start running the program, okay, you'll notice it printed out the menu and it asks for a number. So, and you notice when it did that, the LEDs are all off. So if we enter a 0, turn on the red LED. If we enter a 1, whoops, turns on the green LED. If we enter a 2, turns on the blue LED. If we enter a 3, we get cyan. If we enter a 4, we get magenta. Now you notice that these colors don't always look the way you think they would look. If I look at this directly, I don't see the same color live that I do in this video. So I wanted to show another way that I've done this. What I've done is taken a series of still pictures with a camera that has an optical zoom, and I can get pretty far back and zoom in, and I get colors that more closely represent what the eye sees. So this is the color that I get when I selected red, and I'll step through each of these. This is the color I get when I select green, blue, cyan, magenta, yellow, orange, and white. And as I said, I don't know if I mentioned before, I put a ping pong ball to diffuse the LEDs. You may notice when you look at a lot of videos that are looking at individual LEDs, it's when they turn on an LED and look at it and you see the video that the camera sees, the LED, in most cases, it's difficult to see what color it is. It just blows out the camera and they all look pretty white. You can see maybe around the edge the color of the LED, but it's really difficult to differentiate. And that's the assignment for lesson 12.